Welcome dear students. Today we are going to discuss topic algebra. First of all, let us discuss the definition of term algebra. In mathematics, we have various branches such as arithmetic, geometry, mensuration, and in different branches we learn about different aspects of mathematics. In arithmetic, we learn about numbers and operators. We just play with the numbers using operators. In geometry, we learn different shapes such as squares, triangles, rectangles, and also we learn how to draw, how to construct these shapes with the help of mathematical devices. Also, in mensuration, we learned about surface areas and volumes of geometric shapes. In algebra, we use letters like X or Y. We use letters such as X or Y or other symbols in place of values and then play with them using special rules. Now here these alphabets should be lowercase X or Y, whatever it is, we can use any alphabet but it should be lowercase. So in algebra we use lowercase letters such as X, Y, A, B, C, D, so on. For example, x plus 3 equals to 7. This is an algebraic equation. You will come to know about this in class 7th. And in 6th class you had only know about algebraic expression. That is, expression containing lowercase letters, and these lowercase letters used in place of numbers are called as unknowns or the variable. Here variable is a lowercase letter we use here in place of number. These variables are also called as literals. Basically, the word variable comes from the root word vary, which means whose value can change. That's a variable. A variable's value changes depending upon the given condition. Now, let us first try to understand the concept of variable that we use in algebra. We will try to understand this with the help of matchstick patterns. Now here are some matchstick patterns that we have squares here formed with the help of matchsticks. Now we will observe the number of matchsticks required in each and every pattern and how does it vary. And here we will form a general rule to find a number of matchsticks in a given pattern, and that general rule will also contain a variable, that's lowercase letter, and that variable should be true for each and every natural number. That is, our rule should satisfy each and every natural number. It should be true. First of all, count the number of matchsticks in each pattern. We have three different patterns here. We have to count the number of matchsticks. In first pattern we have 4 matchsticks. In second pattern we have 7. You can count. In third we have 10 matchsticks. Now we will observe how these patterns are formed. For that, let's move to the next slide. We are having 3 arrangements here. First, second and third. In first 1 square, in second we have 2 squares, in third we have 3 squares connected to each other. For square number 1, that is for first pattern, matchsticks equal to 4. That equals to 3 multiplied by 1 plus 1. Now why I have written here this, we will come to know later. For number 2 square, matchsticks equal to 7. That is 3 multiplied by 2 plus 1. Similarly, for third square, matchsticks equal to 10. That is 3 multiplied by 3 plus 1. Now how this pattern gets generated? Let us observe. If I remove the end matchstick from every arrangement, that is, if I remove it from first arrangement, I get like this. That is 3 matchsticks. If I remove it from second pattern, this one end matchstick, I will get this pattern. I will get this pattern. That's like this I get. So you can see that here we have 6 matchsticks, 3 in each C. This C-like structure is formed in each and every case. We have 2 C's here, one first and second. these two C's. In first C, the requirement is 3 mastics. In second C also, the requirement is 3 mastics. If I remove and mastic from third pattern, that is from this, if I remove this one mastic, what I will get? This structure. First C, second C, and third C. So I am getting 3 C's, and in every C I need 3 mastics. That is why I have written 3 into 1, 3 into 2 here, and then 3 into 3. That as the number of squares are added, the mastics also get added. So I can write first case when I have single C, 3 into 1 plus 1 that I have removed. This plus 1 is for each and every mastic that I have removed from all the arrangements. And second case I can write 3 multiplied by 2 because I have 2 C's in second case if I remove the end mastic. That is why 3 multiplied by 2. And in third case I have 3 C's, that is 3 multiplied by 3 plus 1 that I have removed. So this is the arrangement that is formed. Now I will form a general rule and I will substitute number of mastics by a variable, because I will substitute number of squares by a variable because here number of squares can vary. I had to find the number of mastics required for any given number of squares. From the above pattern, the general rule which gives the number of mastics required for any number of squares, that equal to 3 multiplied by number of squares plus 1, that equals to 3n plus 1. So 3n plus 1 here is the general rule. You can put n here, any natural number, and you will get the number of mastics required in a given pattern. N is a variable, that is its value can vary because we can put n 1, 2, 3, 4 so on up to infinity. Its value can change, that's why it is called as variable. With the number of squares, its value change with the number of squares. You will also note it down that variable is also called as literal. In mathematics we call variable literal also. So this was the concept of variable, to form a general rule using the concept of variable. So here is another case of mastic pattern. Here is a triangular pattern. And in first triangle, we have a table also here. Number of triangles, number of mastics. Number of triangles versus number of mastics. In first pattern, we have single triangle. Number of mastics required 2 multiplied by 1 plus 1. That is 3. In second pattern, we need 5 mastics. You can count. That is 2 multiplied by 2 plus 1. Why I am writing this 2 multiplied by 2 plus 1? Why do not I write simply 5? Because if I remove one mastic from a pattern, I get a pattern, that is in first case I need 2. If I remove one mastic from second pattern, I need 4 mastics. That is why I have written 2 multiplied by 2. And in third case, if I remove the one mastic, how many mastics I require? 6. 1, 2, 3, 4, 5, 6. Because I am getting this pattern if I remove the one mastic. So in first case I have single pattern. In second case I have like this pattern, this, then it is like this. So I need 4. In third, if I remove the mastic, I need 6. In fourth, if I remove this end mastic, I need 8. That is why I have written as 2 into 1, 2 into 2, 2 into 3. Because as the number of triangles increase, the number of mastics requires becomes multiple of 2. That is 2 multiplied by 1, then 2 multiplied by 2, then 2 multiplied by 3. And this 1 I am adding because for the mastic that I have removed. This 1 is for the mastic that I have removed. So this is a general rule. Number of mastics equal to number 2 into number of triangles plus 1. Writing x equal to number of triangles. If I write x equal to number of triangles, because number of triangles here is a variable, it can vary. First it was 1, then 2, then 3, then 4, and so on it can go. So number of mastics equal to twice x plus 1, where x is the number of triangle. Here x is a variable. X is a variable because its value can change. So the general rule is twice x plus 1. Now you can find with the help of this general rule the number of mastics required in any given pattern. For example, if I had to find a number of mastics required in 10th pattern, how can I write it? That is 2x plus 1. Now x here is 10, that is 2 multiplied by 10 plus 1, that equals to 20 plus 1, that is equal to 22. So number of mastics required in that case equals to 22. Sorry, that is 21. That is 21 mastics I require for 10th pattern. So you can find number of mastics required for any given pattern using this rule. This is how we use variables. Now here is another case, number of mastics required for forming letter Z. In first case we need 3 mastics. If in second case we have to form 2 Z letters, we need 3 multiplied by number of letters Z, that is 3 multiplied by n, where n is the number of letters. That is for third letter we need 9 mastics. 3 plus 3 plus 3, that is why 3 multiplied by n, that is 3 multiplied by 3, that equals to 9 mastics. So this is how we form a general rule. So this was all in today's lecture. Hope you understand.